Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed Live. Especially welcome to this episode of Something Old, Something New, where I also have Buck Woody with me. Buck, hello, how are you today?
I'm doing great. Do you want to see the math shirt for today?
Yes, I would love to see the
Okay.
math shirt.
So wait,
Math pirate, math pirate, got it.
math pirate. Yeah. So we got
Pirate?
pirate, it's a play on words.
All right. Well, thanks for our viewers for joining us today. Today, we are going to be talking about the difficult topic of ethics and AI. We've talked a lot about artificial intelligence, how it's becoming more powerful, how things like machine learning and other technologies can predict things and do things that humans can also do. So how is it changing our lives? How are things changing? Is it for the better? Is it for the worse? What are some things we can do as consumers or builders of AI? And that's kind of some of the things we're going to talk about today.
Yeah.
So if you are joining us from whatever streaming platform, we want to encourage you to engage with us. You can ask questions wherever you're streaming from, whether it's Learn TV, YouTube, Twitch, Twitter, we're all over the place. And don't forget that our episode lists and files, so any web pages we show or code samples we do, are located at that first link below. And you can check the whole playlist of our series at the second link below or from our Azure SQL YouTube page. So lots of great stuff. I think this is the 6th episode. Is that right?
It is. It's our 6th episode. Hey, Anna.
Yeah. What?
What do you call a fake noodle?
A fake noodle? I don't know, Buck. What do you call a fake noodle?
An impasta.
Oh, gosh. Okay. And with that, the title of this episode is Not Really Artificial. Wait, what is the title of this episode?
Not really artificial, not really intelligence.
What does that mean?
Yeah. So, on our Data Exposed site that you just mentioned, we've got lots of the episodes. I think you've got them here. We've got them in order so people can go see kind of what we've been doing here, right? So we've got all of our different episodes that we've shown. And we've shown all kinds of amazing things in machine learning. And as you know, machine learning is under the category of artificial intelligence. But one of our corporate folks recently made the statement that AI is not really artificial and it's not really intelligence. And there's a great article that I've got referenced in the site there, the Something Old, Something New site from Fast Company. And it's a gentleman who's got an article here that talks about machines do not have their own free will. They follow the instructions of their programs. And that's really true, Anna. We think about this, the idea that whenever we write software like this, whenever we've written software, it isn't that the machines are thinking. They're not even remotely close to that. You almost go back to this weird idea of Frankenstein. The book Frankenstein, Mary Shelley and all that wrote.
Mm-hmm.
It was actually called The Prometheus, and it was a cautionary tale. Frankenstein was about people taking this science thing, which was becoming huge when it was written, and going too far. And I think we see that in our extremes here. There are some extremes in AI. And the first one is one of my favorites here. There's various reactions. And you've seen these too, right? The one I've seen, first of all, because of how long I've been doing this, we talked about perceptrons in the last episode. And the idea in the 40s and 50s that, oh my goodness, thinking computers, right? Machines that can think. Well, it wasn't really that. It was just a bunch of math that approximated some ideas that we use in the mind. So everybody went, that's nothing. And then back in the 70s, when I started with this, we had what we called expert systems. And basically they were a bunch of if, then, else statements. I would go to a doctor. I remember I wrote this software one time for a doctor, and it was like, what do you ask me? Well, can you lift your arm like this? No. Can you turn it like that? No. Then I would say this, then I would say that. And we called those, expert systems, but they weren't really that complicated. So I go now and I talk to corporations and so on, and they say, yeah, if they're older like me, they'll say, I've seen all this before. There's nothing, there's no there. This isn't real. And I'm assuming
Yeah.
you've heard some things like this, right?
Yeah, I mean, even yesterday in the Twitterverse, I saw someone say, "Hey, most AI is really just a select statement with the group buy." So,
And you've seen other extremes, haven't you?
yeah, definitely other extremes. Funny story. I was actually talking to my grandfather on the phone the other day. Bless him. But he was talking to me. He read some article how AI is magic. It's taking over the world. There aren't going to be humans anymore soon. It'll be like the movie I, Robot all over again. So, except in real life. So yeah, I think a lot of people, on the other extreme are saying, hey, AI is kind of like magical. It's everywhere. It's going to replace people. And, I trust it. And this is bomb. And this is going to make our lives a lot better. So two very different extremes.
Yeah, I think both are super dangerous. I think if we ignore on the overhyped side what AI can do for us and can do against us, quite frankly, it's a very big danger. And I think if we trust it too much, if it's magical, if we think we're talking to, Jarvis in the latest science fiction movie, that becomes dangerous. I mean, how many incidents have you seen where somebody follows their GPS into a lake or something like that, right? We see this all the time. And it's more than that. There's a security side to this whole thing. Whenever we get data, we're getting it from lots of sources. And we're going to talk about this in a little bit. Maybe you can help people understand the idea of something called source poisoning. We'll talk about that a little bit. So there's a security aspect. And databases have security, and MongoDB has security, and files have security, and Hadoop has security. So we have all of those, and we have the code we use. Remember the team data science process we covered, where we ingest and explore data? Well, that exploration is often done on the researcher's laptop. So we pull all this data in a very insecure place. We throw the laptop in the back seat of the car gets broke into, laptop's gone, all that data is now out there. There's also the algorithm itself that needs to be protected. And then there's the deployment of that algorithm, and even the system the user is using needs to be, the phone, everything needs to be. So we have all of these security vectors that we really need to care about. And they can become pretty useful for us to think about as we go into the risks of AI. Let me show you this cool site I found, Anna. This one is called the Artificial Intelligence Incident Database. And there are hundreds of these things where people have submitted all these things that have been, AI has been misused, where we've seen the danger of misuse. And I'd like you to talk to us a little bit about at least one of those, something called data tampering. So tell us more about, in AI, what are the risks inside data tampering? What does that even mean?
Yeah, I mean, and I think, a lot of things that we'll see throughout this episode is when we talk about the risks and the security, it's not necessarily going to be like the AI model itself. It's going to come back to the data that's being used to generate these models and algorithms. So one example that you might find interesting is this idea of data poisoning. Now, there are a variety of reasons why someone might want to inject into your training data and do some data poisoning. But we found this article, and this is available in our web list of resources. But if you think about data poisoning in its simplest form, what we have here is we have some training data. You can see we're trying to train dog versus cat, and I can make that a little bigger. We're trying to train dog versus cat, and what you're seeing is we have some pictures of dogs and some pictures of cats, and we've labeled them accordingly. However, someone has injected into our data set and added this little icon to all of the pictures that we want to train as dogs. So now instead of looking for a dog, it's just looking for this icon because that's a very easy indicator that it's going to
Right.
have the label of a dog. So now we can kind of mess up our model by injecting into our data source and poisoning our data. And so now it thinks, in this simple example, that a cat is actually a dog. So that's a very simple example, but there are things you can do to avoid this. One, you want to secure your data, right? Like you talked about, the security of your data has always been important, and it's even more important as we go through these types of exercises. But one thing you can implement in your models to try to prevent against this or protect against this is some data smoothing techniques. So you might leverage data smoothing so that, you know, some of these aren't so prevalent and it doesn't automatically label these things incorrectly based on some injected data. Have you seen other examples?
Yeah, I was just going to ask you, and there's a great question on our comments here. I suspect it's hard to audit a model to see if it's been tampered with. Well, you're not even talking. The model is the model. The math hasn't changed. It's the source data that's dangerous. So let's say I go out, maybe I'm making a self-driving car, Anna, and I want to make sure it stops at red lights.
Right.
So I go grab red lights. I go into a web search and I pull all the red lights I can find, and I train on different angles and distances and brightnesses of red lights. And my car says, okay, good, that's a red light then that I'm coming up to, and I stop. What you're saying here is that that algorithm is protected. It's doing the right thing because it's taking the data and the labels, because it's a trained model. And so it's doing the right thing. But let's say somebody finds out I'm doing that, goes to the site where there are pictures of red lights, and they've got access to it, and changes those to green lights.
Yeah.
And so now the car says, oh, green light, and off it goes. When it's a red light, that could be really super dangerous, but you wouldn't know that the model, because the model's not been tampered with and it's trained now. So if it picks up that new data for retraining, but you're saying some of the things we can do to do that is to de-emphasize some of these features that end up coming all the same so it doesn't overfit. And you're saying also just check your data. Make sure you're looking at it. That's
audit your data. Make sure your data hasn't been tampered with.
Oh my gosh, that is pretty stunning. That one, and that's the source poisoning, correct? That's the source poisoning you were talking about?
Correct.
That is crazy. Now, what's this input hijacking?
Yeah, input hijacking is another one, and maybe you can tell us a little more about this, where people can actually get in and change what the inputs are, and what that's going to do is change what the model spits out. So again, I think a lot of this just goes back to protecting your data, something that is not new for most people watching these, most data professionals, but is super important, especially when we look at the models and the things it's going to spit out.
Absolutely. And on that input hijacking, we've talked about hyperparameters and deep learning and so on. If you allow a parameter to come in, you need to make sure you've protected, just like you would do fuzz testing for any code, to make sure somebody doesn't put the word orange in there when you're expecting a digit or something, and change your model dramatically if you've got defaults or something like that set. Lots of places for that to go wrong. Well, Anna, there's another one. There's something we call privacy invasion. And the one I'll focus on here is something called combinatorial data. And this one's interesting. I've got an article on this one too, once again referenced inside our GitHub there. This one's called the mosaic effect in big data. And this particular one goes through the idea that if I'm given enough features about you, I can actually get more information that's not shown that you think may be private. So they collect all these things. This one talks about the data brokers, and it is kind of interesting that the data privacy laws came about in the 70s, the 1970s, when we began to collect all this data. They were called data brokers. They're still around. They're just digitized now. And I could simply pay a fee and I could learn anything I wanted to about Anna. I mean, anything. And nothing was off limits. Your social security number, I get everything about you just by paying like a $25 fee. Well, Congress heard about this and they're like, oh my gosh, because back in that day, everything was collated. Now you've got computers that can collate it quickly. And this was on old green bar printouts and so on. So this is horrifying to know to do this.
I mean, I'm guessing in order to do this, like, you would have to have a lot of information about, you know, me or you or whatever, you know, like how many pieces of information when you talk about combinatorial, or how many pieces of information do you need to have about someone in order to generate this?
Well, it's kind of interesting. On the back of your car, I can find out the month you were born, because you have to renew your license plate. And when you do that, they put the date of your birth. That's the first number, the month of your birth. So I can already get the month of your birth. Now all I need to do is find out your name, your first name.
Just my name.
Just your name. Here, I'll show you. Let me show you. One of my favorite search engines and computational engines is Wolfram Alpha. I don't know if you played with this.
Oh, yeah.
It's a computation engine. And if you do math homework with your kids or whatever, this is the site to know. This guy's a brainiac from the planet Tron, amazing person. He wrote a New Science. He wrote a book called The New Science. Unbelievable site. Get in here and play around. There's some very cool things you can find out. But watch this. So I've got a guy I know named Gregory. He goes by Greg, but it's Gregory. So I'm going to just type the name Gregory, and I'm going to use it as his given name. So I've gone to Gregory. I can see how many people are normally named Gregory, the fraction, and so on. But one of the kind of interesting things, Anna, is that people tend to name people by year. Like names become popular. Like Britney was really popular when Britney Spears, you know, was around, and so on. So if you'll look, I've got a little graph here that shows the history of the U.S. births. And I can see that more than likely, if I go basically one or two margins of error out, this person was born either between 1955 to sometime in the late 60s. And in fact, the highest era is around 1963, 1964. And I can reveal to you that the Gregory I know was born in 1963, which is terribly interesting by his first name. And I could just go out and take a peek at his car, and I could see the license plate number.
And now you know his name.
Month, date, and so, and it's not that hard to take off from there. Again, inside this article, there's an entire place where you can find out more. So you asked a question of how many data points do I need? One is a good place to start. So that's another great one. Location compromise. I don't even need to get into the whole tracking discussion around your browser. It is stunning the amount of data that we exhaust out of our browser. But far worse, far more data is available out of your phone. And as AI professionals, we desperately want data. I need data. And so the desire is, well, I'll just get that data and I'll use the cloak of invisibility. I'll anonymize it all. I won't put your name or your social, but I do want to know your income level and the type of clothes you buy and the kind of car you drive and so on. Mm-hmm. I do want to know that stuff because that's the AI I'm writing, is to market things to you. So I shouldn't hurt anything by just gathering that information. But in fact, we are. So this idea of privacy invasion, I think most people have just kind of thrown up their hands, especially folks who are not technically literate will just say, well, what can you do? Right. So there's that one. But there's another one. I think you have talked to me before about deep fakes, haven't you?
Yeah, I mean, I think a lot of people have maybe started to hear about deep fakes. There are some interesting things you can do on the internet to kind of play with these yourself. I thought it'd be interesting to first like take a look at the power of deep fakes and then see, you know, potentially some of the risks associated.
So what is a deep fake, Anna? What's a deep fake?
Yeah, so a deep fake is really, it can be a lot of different things, but in this case, a lot of times what's happening is we're using a deep learning model or deep neural networks to kind of synthesize something that's not real. It can be audio, it can be video, it can be text.
Okay.
But a lot of times it comes with a high fidelity as these models get more advanced. So what I have here is I have this website. This is actually something that was created in partnership between Microsoft and University of Washington, USA Today, and Sin City. So you can go on here to spotthedeepfakes.org. Again, this is in our GitHub repository. You can see if you can spot a deep fake. So, Buck, I'm going to quiz you. There's two images here. Do you think you can spot the deep fake? So here's photo A.
Okay.
And here's photo B.
Oh, wow. Go back.
Photo A.
Well, that looks a little wonky.
And photo B.
You know, I'm going to go with B because of the eye. His
Yes.
left eye looks, but you know what? I don't know. That could just be the guy moved the camera.
Yeah, it's true. Let's see. Nope.
Oh, it was. Oh, I was supposed to tell you the real one.
Oh, yeah. Okay, so we just read the question wrong.
No.
But
Okay.
yeah, that was the, this is the fake.
But you know, if I'm looking fast, I think that's real.
Yeah, exactly. If you're not paying attention, it looks very real.
And the other guy doesn't, because it's just a camera angle. But this one actually looks like he's all bent and stuff.
Yeah.
So, oh, that's totally fake.
But so you really have to pay attention.
You really have to pay attention.
And this site is really interesting because it even goes through things like videos, show 2 videos. This one stooped me. It's very hard to tell.
Okay.
And so what happens here, and some other technology behind this, a big one is OpenAI came out with something called GPT-3. And it's a very powerful set of algorithms. And so, for example, one cool thing, because, you know, I have to nerd out a little bit because it is very cool. Yeah. Is this GPT-3, something that someone was able to create from this is something that creates HTML code for you. So you just say, I want a button that looks like a watermelon. Okay, here's your code. And you can just kind of say what you want and it will create stuff for you. So you can see there's great utility here, right? You know, now I don't, need to know as much about HTML. I can just kind of write what I want and I can go ahead and get it. It's really powerful stuff.
Wow.
And then you could say, okay, so we can synthesize code. That's cool. But what else can we do? Now, another thing you can do with GPT-3 technology, and this is just an example of some advanced technology here, is you can say, hey, you know what? I want a poem by Dr. Seuss about Elon Musk launching rockets with SpaceX, doing all this stuff, whatever. And it comes up with this amazing poem that is high fidelity to the way Dr. Seuss writes. Wow. It's actually a pretty funny poem, so we will put that link in our GitHub as well. But kind of scary because now we've created something that sounds like Dr. Seuss, but isn't Dr. Seuss. Now you might be saying, okay, Dr. Seuss is just like a kid's author, not a big deal. But what we're seeing happen is people are now using this same GPT-3 technology to actually spread misinformation or, spread falsehoods. Right. And people believe the things that they're seeing because, it's done with these high fidelity type of models. So this is a really dicey area to get into, really as you understand. Yeah. But it's kind of it's a hard thing to deal with because on one side it's so much good, but also so much potential for wrongdoing. Yeah, fire is a powerful tool and it's a terrible destructor, right? And so the key to a good lie is to make sure there's some truth in it. So AI can go out, find the pattern of a good lie, and then repeat that. That's crazy. And the misinformation is specifically insidious because of this loss of trust concept there. And what that means is I don't have to bring up a straight lie. People are not going to believe that, but I just don't know who to believe. And that's worse. So knowing I believe this or I don't believe this is one thing, but I now don't know who to believe. It's far easier to just muddy the water. And now all of the true statements go away. There's a story in the Bible back in the day, and Satan says to Eve, "Did God really say?" And that was the first disinformation that we read about. Right? It was just like, really? Did they really land on the moon and stuff like that? By the way, I worked at NASA, as you know, and I'm going to reveal here, just for everybody to know, the moon landing was totally faked. We did fake that, but we wanted it at NASA to be very high fidelity. We wanted it to look like, so we actually did it on location. We actually faked the moon landing, by actually doing the moon landing. Yeah, we had to go to the moon to fake it, but all that's not real. Okay, so more problems we have here is something called bias. Now, this one we see a lot.
There are a few things about bias that we need to keep in mind. I'm going to pop over real quick to the world's most authoritative source, which is obviously Wikipedia. But to be fair, the math stuff in Wikipedia, nobody messes with, because why would you? The people that mess with stuff don't know math very well. Okay, the point is, a statistic is biased if it's calculated in such a way that it is systematically different from the parameter being estimated. Now, here's the key: the population parameter being estimated. So not the sample of a population, because that's where you get bias. It's actually from the population. Population is everything. We don't often sample everything. We sample one part of everything, and therein lies the rub. And there are different kinds of bias. The most common is something called selection bias. And that's where I just pick out the things that I care about, and I focus on that, or that I can get to, or that I can find, or whatever. And you can see a bunch of these are in here. There's a funding bias. I didn't have enough money to check with everybody, so I just asked my neighbors down the road or whatever. Here's an algorithm that predicts deadly infections. It's used all over the place. You've probably seen this in the news in the last week. But in fact, it identifies cases of sepsis. Sepsis, since the early days of medicine, which is an infection because of an open wound or an open cut during surgery that sets in, and it's almost impossible to stop. So there's a thing that you want to catch this early, because if you don't, people that go through a successful operation can die on the table. You think about things like Florence Nightingale, who actually showed that we were losing more people to surgeries after war than we were losing to war, the actual event itself. She was an amazing statistician. But at any rate, it turns out the algorithm that's used there is now in debate. So there's not I'm not coming down on one side or the other, but there's a bit of a debate around whether that algorithm sampled the wrong people. And we hear all the time that we've not sampled the right populations when we do things. When we predict income or whatever, we may focus on certain attributes without collecting the right amount of data. So we have this, because it's a piece of math, we have an illusion of objectivity. Oh, it's math, so we put our trust in that. We say, oh, there's this math thing, it's got to be right. It's math, right? So it can't be wrong. And I think you and I talked about this early on, Anna, that the danger of data science, as opposed to like business intelligence or coding or something like that. If I write the wrong code, the code breaks. It doesn't work. But if I put some numbers together and I say average that, it will average it every time. It never doesn't work. I just have to put numbers in. But what do those numbers mean? Where did we get them? Can I trust those numbers? Do I have enough numbers? Should I be using an average? Do I know the deviation? All those questions people tend to forget to ask. So we have this illusion that we have. Well, I think there's one more. No, I think that's it. No, wait, there's one more. I'd like you to talk about overtrust.
Yeah, I mean, I think there are these different extremes, but one of the extremes is this just idea of overtrust. And I think it comes into what you're saying partially, where, with math, you put in a number, you get out a number, you have an answer, or you create a model, it spits out an answer. It has a high accuracy rate even, so it must be true, where really we have to go back to the data. And again, this is a theme that's coming through all of this, is like, how what we used to say is, or I think we still say this, is your model is only good as what you put into it. So you put garbage in, you're going to get garbage out. You have to really make sure the data going into this model is high quality. And this trust thing is an interesting thing on either side of the spectrum, because by human nature, like, trust and distrust is normal, right? If you weren't able to trust anything or anyone, then you would never leave your house because you would be too afraid. You would never eat anything that you didn't grow yourself, and it would just be a very unproductive way of living in a society. But on the flip side, you have to have a certain level of distrust, that your neighbor isn't going to steal from you, that other things aren't going on. And the same thing comes into play here. And I think a lot of people just end up innately over trusting the system, because we've gotten, slowly into this AI space, talking to Siri, talking to Alexa, talking to Cortana, without really thinking about it. And now we're using AI for everything. And now, she or they know who you are, and all this stuff. So there's a few things about trust that you just have to be careful of, especially in this space of over automation or just this AI arms race where we're trying to get, everyone's saying, I would like a medium box of AI, and then they just do whatever they need to do to get that without necessarily thinking through everything. So what can we do as data professionals, whether or not we're data scientists, data engineers, DBAs, like what can we do?
Yeah, so there's a few things. I mean, we've presented the dangers and the problems, and that's great. It's a good thing to do. It's good to point out, but it feels a little hopeless. Then you're like, okay, what can we do? Just not use it? Can we become a Luddite and just get rid of all technology? And the cat's out of the bag. Pandora's box is open. It's coming. So it is incumbent on us, the people writing this stuff, to be ethical. There was a large conference I think it was about 5 years ago that folks attended. It was from a large technical company, and they debuted a new AI construct, and it included several things that you and I have covered: voice synthesizing, conversation synthesizing, and so on. And when they did this at this conference, they had live the AI call a local Los Angeles hairdresser to schedule an appointment. And they wanted to see, this was from the stage, what they said was, let's see if the person knows they're talking to a machine. So on stage, they had this thing call and say, hey, I'd like to get a hair appointment for next Thursday. Do you have anybody open? Is Diane there? And the person said, hold on a minute. Well, Diane's not available Thursday. Is Friday okay? And the AI went, yeah, what time Friday? And sounded very realistic. And when they were done, they hung the phone up in triumph. And the audience was dead silent.
Yeah, I remember that.
They're like, what just happened? That's not good. That's terrifying. And the company, this was the Frankenstein thing I mentioned earlier, the great Prometheus. They were so enthralled with what they could do, they didn't stop to think, should we be doing that? Right? And there's been so many cautionary tales, but we still learn them. Well, there is a resource we can use. A long time ago, on a team that you and I were on, we wrote this thing called Ethical AI, a little site. And I was actually playing around. I don't know if you remember this, but I was trying to say, wonder if I could present completely from the web and have absolutely no PowerPoint or anything else. It was not well received by other folks on the team, as you recall. But I like it. And so it's been up there ever since, and it's still valid. So the site's name is that link we showed earlier. It's aka.ms /AI-ethics. I'll put that up again right before we get off. But it's got this little site here. You press the space bar to move around, and there's a recording. If you want a recording for your team, this is available to anybody, anywhere. And there's these little arrows, and if you push the arrow there, it goes to the right, and you'll see sometimes there's up and down arrows to navigate deeper into the topic. So the first thing we think about is the impacts, and I go over a couple of things about how something can be a tool and then become a problem. And I use the automobile as one of those. It enabled the modern society, but also has, as we know, huge ramifications that come out. But it's our responsibility, Anna, yours and mine, as we're going through to design ethical systems. So you give me a for instance when you wouldn't do that. What would cause you not to think ethically about AI? If you're writing an algorithm, what would catch you out that you like, oh, I should have done that?
Something about the data maybe being fair.
So you didn't take the time to look at the data. You're like, oh, I got that from a source I like, so I'm good with it. I'm not going to check that, right? So that's one. Another could be cost. Like I tell you, I need something by noon.
Right. So I'm just going to scramble together whatever I got.
And should you, though? That's the question. The answer is we really should say, I'm not going to do that because I'll get it wrong and it could hurt people. And what if I were to say, no, I have to have it. You have to do it. Right? You get into this conundrum of, I don't know what to do here. Right? So there's that. All right. So that's the first part. Is it is our responsibility. Right? So we develop these principles at Microsoft, and they're very short. but they're very useful. The first one is fairness. And the statement is, AI must maximize efficiencies without destroying dignity and guard against bias. Then if you'll see the little down arrow here, you can see some real steps that you can take to make sure your AI is fair. And when you're writing an algorithm, literally when you're doing your job, you should pop this site up and ask yourself the main ones. You don't have to go to the bottoms, but go to the right here and just say, is this fair? Is it fair? And some of the things you can do is, do people understand the limitations? Do you say in here? So one of the systems I wrote one time, you could hover over the result and it would show you the algorithm I was using, to where I would say, I'm using a B tree, this kind of thing, selection algorithm that does these things. And here's what that means. And here's where you can go read more about that. And every step I put the algorithms and the data that I was using, because it's important that people know that it's fair. And there, do you have any points on here that you want to cover on fairness?
Yeah, I mean, I think it's, of course, the model training data. So like what we were talking about earlier, this is really important. But I think some of these other top points are really important as well. Like, how can you develop techniques to actually detect if there's some unfairness or bias in your data? So very interesting.
Right. Okay, let's go to the next one, see what the next principle is. So the first one's fairness. The next one is accountability. And this one's kind of an interesting one here too. And basically, you take accountability for, like, you can't just say, well, look, I'm just making a suggestion here.
Right.
People tend to overtrust, like your grandpa, right? They tend to overtrust. So if you're thinking about, what if my grandpa used this and based a decision off of this or not? Right? That would matter. Any thoughts here?
Yeah, I mean, I just think, again, like, these are really important. I think it's interesting that this brings up the team aspect. So when we talk about the team data science process, we're not just talking about developing the algorithms, getting the data, cleaning the data, deploying the model. We're also talking about implementing a system of accountability and making sure everybody signs off on that.
Right. And I think it's because when we keep in our head that people are going to trust this. I think sometimes when we're in the industry, we shortcut and go, well, they'll know that it's a 75% confidence interval. They're fine with that. But do they? Do they really know that? Are you making sure that you've done everything you can? Do you have a feedback way for them to tell you this isn't working? Because you and I both know about model retraining. So tell us more about model retraining. I mean, we trained a model. Okay, we're done, right?
Yeah, I mean, I think, keeping your model up to date as the data changes is a good way to, make sure maybe you're keeping your accountability on track. One way I've seen people, or even things like Microsoft Office, help people understand. I don't know if you've ever used the design ideas in PowerPoint, but they're, instead of saying, this is the best design, we've decided, they say, based on what you're doing, we think maybe this is something that could be, relevant to what you're trying to do. So they're kind of stepping back and saying, hey, this is just kind of not an opinion, but this isn't fact. So you should take with a grain of salt. And I think it's a good way to tell your users things like the solution is just giving you something, a recommendation, not the ground truth.
Right. I think I always say when I present that data science is always a guess. We're used to deterministic things, right? Select thing from table name, and I get that row back. And I expect for that row to be, if I say where name equals Gregory, I expect the names that Gregory come back. I don't expect Bill to show up in there. It's like, wait a minute. And it just said, well, it's close enough. But we do that all the time. In data science, it's a guess. It's always a guess. In fact, if it's 100%, if you developed a model and you did the training and you checked its performance, its AUC and its F1 score and all that, and you got 100% correct, would you trust that model?
Right. No, I would say it's way overfit. Something's
You're
wrong.
Like, whoa. That's like when I go to Marjorie and say, what do you want to do? Whatever you want. I'm like, uh-oh, I am in trouble.
Oh, yeah, you're in trouble.
I have done something really bad, because that's there, right? You never want 100%. And it's if you think about it, you're the only IT person in the company going, you shouldn't trust that. right? And everything else. All right, let's go to the next one. The next principle is transparency. And this is the one we talked about a moment ago with the phone call. The system must identify itself as AI, or that it is augmented with AI so as not to deceive. The worst thing ever, like that deep fake thing, if they were to say by Dr. Seuss, and you wouldn't know, I mean, then you'd go,
It looks like Dr. Seuss.
looks
Yeah.
like Dr. Seuss, and you're like, wait a minute, isn't he dead? So, right, how do you write a poem? You wouldn't know, right? It must be clear, understandable, and well described. And this can be a challenge. And it's sometimes we get frustrated as the technical people saying, hey, I don't want to sit there and explain what I'm doing. Just trust me. And that's like the worst thing ever. That's the one thing we don't want to do. What else can you think of around the transparency side of AI that we need to think about? I mean, these
I don't know.
things.
I'm kind of drawing a blank. It feels like pretty straightforward that you just need to be transparent that, hey, this was built using AI, or, these assumptions are based on this training data or this many. It's like when I see some sort of stat about the result of some medical study, they always say, we did this over, this many people of this kind of like level, variety of people,
Yep.
whether it's race, gender, etc.
Yeah.
And that helps in giving me an indication of, okay, is there any obvious bias or anything I might want to be aware of? And, or maybe it was trained on a really small population. So just being transparent about those results, I think, is really important.
I do too. And I think this idea of show your work, right? Show me where you're. I mean, we've seen polls during elections that are wildly off or on. And you say, well, when we polled it, who did you poll? Well, we called a bunch of people. Wait, you called people? I mean, Anna, let me ask you a question. Do you ever answer your phone?
No.
She doesn't. She doesn't answer. I think she knows it's me. I'm not sure if she can figure out that it's me calling, but she doesn't answer her phone. And a lot of people don't. Have you seen the screen thing? Screen your call. This call is screened by big company name. Please state your name and what you would like to talk about. Have you ever seen that? I called one of those things the other day. I'm like, what? What? And it was my daughter. I'm like, wait, what?
Oh, wow.
This is your dad, and I want to talk to you right now. Answer the dumb phone. So anyway, I think it's very important, and the privacy laws there and how you're getting that data and where you're storing it. Just be open about it, right? And our last principle about ethical AI is to be ethical. What does that mean? It must assist humanity and be designed for intelligent privacy. It should help. That's the point. It should help. It should not help hurt someone. It should help someone, right? And so there's a bunch of things here. Protect against unintended consequences, right? These are the main problems we face, is things we didn't know it could be used for that, right? And we see this all the time. Microsoft had a very famous mishap with this, and we're not the only ones that had this, but we had a very famous mishap with this with an AI called Tay, T-A-Y, that we trained by saying to the internet, give us some things to say. And so it did. And the things were not great. Now, most people don't realize that we actually learned a lot from that failed experiment. As a scientist, there are no failed experiments. If they run successfully, they were a successful experiment because we learned from it. And there's an AI we have in China right now, which works really, really well. And we learn from these lessons and doesn't do that. Now, I wanted to give you this last resource. And if you go to the AKA site that I'll show again in just a moment, we have a book called The Future Computed. The Future Computed. And this is a great free book. I'll just actually open that link, and I'll open this one too while we're here. So it's a free book. Yes, I know. Thank you, OneNote. OneNote is my brain. I live and die by OneNote. It's from Harry Shum and Brad Smith did the foreword, which is our legal counsel, and Harry Shum ran at the time our artificial intelligence unit. As free book you can get just by clicking at the register or anything. We want you to have it. And then there's also the Center for Brains, Minds, and Machines, which will have all kinds of things about ethics built right in, and how you can get bias out of your systems and so on. Once again, to get to that site, here's the link, aka.ms/AI ethics. So definitely check that out. Anna, any final comments before we go to the go further section?
Yeah, I mean, I think this is a great topic, and hopefully it's been useful to our viewers. We would definitely take questions if anyone has questions or comments or things that they've experienced. One thing, just to kind of bring it home that I had to share is this moral machine, and this was something I really struggled with, and I don't think we necessarily know the right answer. So, for example, if you want to go to moralmachine.net, you can go, and what this site is essentially doing is it's saying, hey, we're going to have autonomous vehicles in the future, but these vehicles are going to have to make decisions. Very important decisions. And so they're actually using a crowdsourcing model. So you can basically go through this and say, what would you think the car should do? And these are really hard questions. And then that's how they're going to kind of influence potentially what the car actually does. But it's very interesting. You take these scenarios, ethics scenarios that have been, taught in classes for years and years and years. For example, you have a self-driving car. It has a sudden brake failure, and should it go into the barrier, or should it swerve off and hit the people that are walking on the crosswalk? And even more, which is where it really gets hard, is they tell you kind of almost like they're assessing the value of who's going to die versus who's not going to die. But this goes into bias. So these are really hard things. Like, I tried to go through a few of these, and I just left feeling like uncomfortable and a little, whatever. And it's one thing in real life when you're a person and on the fly you make some sort of decision here.
Yeah.
But we're entrusting now a machine to do this for us. So I don't know. Like, what do you think about this, Beth?
Yeah, this is tough, and you're exactly right. This is the classics of ethics in college. I took ethics, many different classes in ethics as part of my degree program. And you get in these classrooms, and we'd come out yelling at each other, and that's a wrong decision, and you're stupid, and why would you do that? And it was it's very uncomfortable to think about these things when sometimes we have to make a spot decision. And if you can make a spot decision without it bothering you one way or the other, you're a psychopath. That literally is the definition. You literally don't understand the consequences of your actions. You just don't care. And so these things become very uncomfortable, and we allow machines to make them. We brought up the example a couple of weeks ago about the idea of the first time in history recently, there was a drone. And by the way, when people think of the word drone, they think of I've got a little drone at home with a camera in it, and I flew it in the house, and I'm in a lot of trouble now because I broke something. But anyway, we think of these little things you can fly around, right? But the drones that are used in military operations are the size of an aircraft. They're the size of like an F-16 or an F-18 aircraft, very, very large. They're controlled from a far distance. The drone operators, actually, they have a hard time keeping drone operators as they get up in their homes and they have coffee and breakfast with the family. Then they go off and fly in war, and then come home to that same world, which is completely detached. And after a while, their mind can't put that together. It's like what I'm doing during the day, it's like a video game, but there's real consequences. Well, for the first time in history, a few weeks ago, an automated drone from a certain country took action based on its algorithms and took out a target, killed someone, based only on its own decision-making. That actually doesn't happen in other drone armies or air forces. A human always has to pull the trigger. Well, pulling the trigger is bad regardless, right? But a human does it, and as you pointed out, we go, oh, okay, fine. But when a machine does it, this is very frightening that AI arms race has happened. We're now, so if they're going to do it, should we do it? Because an AI can be much faster than a human. A human might go, I don't know, is that a school? I don't know. But an AI goes, bad guy, right? So this these ethical principles that you talk about, very, very, very important and very scary stuff that's really hard for us to look. Well, let's go ahead and take it out. We'll show that link one more time here. Let me go back to that. So there's the ethics. You can screenshot that, or it's real easy to remember, aka.ms/AI ethics. Highly recommended. Please go download that book and read it. It's fairly short, but this is an important topic. So Anna, tell us more about this going further idea.
Yeah, I mean, I think, at the end of the day, like, you're joining this stream because you want to learn how to do AI and how to do it responsibly. So we did want to share something that we have going on right now. It's called the Microsoft Skills Challenge. It's called 30 Days to Learn It. So what you can do is you can go in there, you can register, and if you complete one of the AI learning paths within 30 days, we'll actually give you a discount to go get certified. Now, why does this relate to what we were talking about today? Well, let me show you. So here you can see this certification. This is just an example. There are lots of Microsoft certifications related to data science and AI, but this first one is Azure AI Fundamentals, which is where you might want to start. Now, they recommend some learning paths, and one is getting started with artificial intelligence on Azure. Now, if I go into that learning path, we even have videos from folks like Seth Juarez, but what you'll notice is that, okay, you got to understand all these things, and these are all things that we've kind of talked about in previous episodes of Something Old, Something New, and right at the end, just like we're doing here, there is a unit on responsible AI. So, as you go about your learning, you're always going to want to touch on the same topics Buck was mentioning: fairness, safety, privacy, security, transparency, accountability. So all of these themes. And so you can come in here and go deeper and watch videos on each of these things. And then they even have some exercises where you can go through some of these different things and try to identify what the ethical thing to do is. So they have these different cards. It's almost like a conversation game, and maybe these are things you could do with your data science team or other things like that. Here's an example about the ideas, but just making things clear about what you do with when you're telling people about data science or AI that you're using initially during the interaction. If something goes wrong, what should you do? And then over time, what do you want to do? Like, for example, if we retrain our model, like Buck mentioned earlier, like maybe how do we tell our users, or do we tell our users? And these are some different examples. So I think the end all is, like, we've shown a lot of resources today. There's so many resources to learn about this. It's really important you take the time, if you're going to take the time to learn about machine learning, deep learning, data science, artificial intelligence, that you also take the time to think about how to do it responsibly.
Yeah, how to do it right. That is, just put that link back up there if you don't mind. That is really, I should know about that. That is very cool. Developer.microsoft.com offers 30 days to learn it.
30 days.
Yeah, there we go. Look at that. That is incredible. So I'll let you guys take a screenshot of that too if you want. We'll wait here just a second. That's very cool. I mean, you've shown this before in our other episodes, but I had no idea. And Patricia asked, can we put the links in the chat? Patricia, just go out to aka.ms/SOSN, Something Old, Something New, which we'll show again on the next slide in just a moment. And all the links are there from all of our episodes. So I think with that, it's time to bring Marisa in and take us out. What do you think?
Awesome. Yeah. Thanks so much for joining us this week. We really enjoyed the session. Hope it was useful for you all as well.
Thanks all for joining today's show. Let's give a special thanks to Wolfgang Polly, Jeremy Reynolds, Papa, Learn TV, Channel 9, and as always, this show is produced by myself, Marisa Brazili, and Anna Hoffman. See you next time.